welcome everyone. And so again, another stream here for the nodeFlow Discord server. I opened up looking for people that, like me, who enjoy to build things and to share them. And so today I'm not alone. The other time, so today I'm not going to be like a madman talking to myself with jazz in the background. I have Adrian, Mark, and Spinny Normal making some company and also showing some of the stuff that they've been doing. So at times we challenge ourselves with things in the Discord server. And so this is a thing that I saw going around, and I decided to say, hey, why don't we do something with hexagons? And so Adrian has done it for Houdini, and it's gonna go through what were the steps or the idea from start to finish to do the array, or the, what are you gonna call it, Adrian? The 2D array of hexagons.
Yeah, I don't know. I just call it point instancing, but yeah.
Okay. Okay.
Cool. Shall I crack on?
Yeah. Carry away.
Cool. So, hexagons have a. I'm not sure like how much we want to go into this, but just we'll cover this bit super quickly as we're at the start. As you call it, 6 triangles, same size, sides, 60 degrees, 60 degrees. So we need to make a hexagon, and then we need to make a nice grid for them to sit on where they all line up together. 2 different hexagons that we can make. I've made them here in Vex, but not for any particular reason, just exercise really. I know you can just drop down this circle node on the easy one, so this to polygon. 6 divisions. Right. There we go. Just take this off. So here, hexagon in Vex.
So you distributed 6 points and you connect them with.
Yeah.
Okay.
So here, just a for loop. Second web page probably be useful. Polar to Cartesian coordinates. Radius, cosine of phi here, but theta in the code it doesn't really make any difference. So pretty much rebuilding the circle. So we've got a resolution. How many points? There's a Houdini has pi as a function you call it. I don't think it has one for tau. So
I was wondering if there was like I don't know, is that's not a Vex function. Like I'm a bit late to the train, but so we see that they're trying to transition out of those.
I don't think there is a Vex function to grab pi. I know you can do it this way. So this is easier.
Sure.
Is getting 2 pi, storing that as a float. I'm really sorry, Mark, if I'm screaming my cursor around the screen. I'll try not to do it too much. We make a primitive in an integer prim. All of these add prim, add point, add vertex they'll kind of crop up a little bit, but this is basically just making geometry in Vex. In order to make a closed piece of geometry, we need points, a primitive to essentially kind of like have them all on, and vertices to make sure that everything's joined up and we get a nice face to it like this. I suppose we don't just get like a polyline.
So if you change that to 7, we can see
so we can do
a 7. Yeah, okay.
8.
Cool.
So theta step, we just divide 2 pi by the resolution, just cast that to a float. I'm not actually sure if that's necessary, but good practice. And the radius, which I've got a channel call here, so the user can say how large they want it to be. This actually links into this radius here, which is my kind of master controller, which I guess I'll kind of come back to later because it controls the whole
setup. Yeah.
Yeah, I think if you're going to build something like this, it's nice to, as for me at least, as a practice, to try and make it, make it robust and HDA-able. So if you were to wrap this up, someone could go off and make a hex grid of 100 rows, 100 columns, etc. Yep. So this bit's super simple. For loop, start at 0. We're going to run up until it, and every increment of the loop, we are going to add theta step, which is going to be our 2 pi divided by the amount of points that we want. So that means that this loop here is going to run 6 times. We use add point to make a point, and this is where the probably nice if I display this here. Our polar coordinates coming in, cosine of theta times the radius, sine of theta times the radius. And so if we look at the point numbers, can everyone see those okay?
Yeah.
Are they coming through on the screen?
The vex,
0, 1, 2.
The vex, not so much. To be honest, I did quite the mistake of not doing what Mark said, streaming directly. But
yeah, I'll give everyone the hip file so you can all thumb through it at your pleasure later.
Sorry about that. Yeah.
Oh, that's all good. So for the point 0, we have to use the set function because we're creating the vector dynamically as we go. It's not a constant. This is gonna change. So to find the x component of point 0, we can see it down here, point 0. X component is 0.5, so this here evaluates to 0.5, and sine of theta times the radius evaluates to 0.866025, which is this little point down here. Yeah, as we can see, right angle triangle makes it nice and easy later on for how much we're going to want.
Yeah, it's nice that you did a polygon to deal with those too, because I thought about them in separate, but here you made sort of a construct that sort of acts like a library.
I mean, this
for
was
all those distances.
Yeah, this was really for my benefit, because what we were saying before was when you do this for other people, you want to really make sure that you understand it so you can explain it to other people.
Yeah.
And you can sit there and just like bash away and think, okay, cool, yeah, I've got a hex. But yeah, until you've really broken that down, it's kind of easy to overlook a lot of things. Yeah, getting back to math is kind of nice. So this is a flat top hexagon, so we can see here, flat top. We just grab up our hexagon here. Difference between two orientations is that the x and y are swapped. In our case, it's x and z because we're slapping it flat on the ground. If you want to make a pointy top hexagon like this one, is we can just swap the arguments over. So rather than having the cosine of theta times the radius for your x component, that will become your z, and sine of theta times your radius is the other way around. So pop that there, pop that here. Same thing. Now, obviously, the nice thing about this and having this as a visualization is it becomes very nice knowing this length, the origin and the edge. We know that this is going to be where we're going to want the origin for our next hexagon, and so on and so forth. So this number is going to become quite important. And that's why, and if you're seeing like a difference in things, some things just kept as variables. These are things that exist only within this wrangle and they don't go anywhere else. Some things I make into attributes, so I've got access to them later. Just become a bit more. They're just useful for things that I found as the process of making this. I was like, oh, I need that value for centering the grid or whatever we do. Get opposite out into a separate wrangle just for kind of clarity's sake. Really, there's no reason this doesn't need to be done.
The same one, yeah.
Yeah, you could just pop this code at the end of it, and it would be fine. But basically, that's it. All we're doing is we're just getting. I've called it opposite because that's what I've known this as, the opposite of the hypotenuse. We just want to get this distance here. So, I mean, technically, we already have it from the first one, but again, this was for really my visual benefit and everyone else's. Yeah, sine of theta step times the radius. And this was another reason that I've had this as an attribute, so that when I call theta step, that exists as a detail attribute. So these wrangles here we run in detail mode just because there's no points to run over, so it wouldn't work if I put it into points. But just because we want this to run once, as it says.
Yeah, there's no
run
need.
Once, execute. Yeah, you don't. There's nothing for it to. That's the hexagon.
Okay.
Yeah, again, it was just really an exercise. It saved me a node because it meant I didn't have to get this circle and put a transform and rotate it 30 degrees. So that was nice.
Yeah, this type of exercise that you've done there is also useful when you want to do in abstraction a polygon with x size sides. Even if you don't want to display it, you want to treat it and you want to manipulate it. But so it's nice to have a builder like this. Yeah.
I think that geometry creation in code is obviously one of the. It's just such a cool thing that you can do with Vex. So any practice that I can get in playing around with that is pretty good for me. Okay, so moving on, making the grid. So let's just pop this up, zoom out a bit. So at the moment, this is 100 rows, 100 columns. Maybe we should just tone this down. Nice controllers, just to make it as big as we want. Nice. The one thing to note here is that this pipe is actually going into the second input of this wrangle. And again, that's only because we need to grab a bit of information, or I wanted to grab a bit of information about the hex. You could do this assuming that the input would always be a unit hexagon with a radius of 1. But I wanted to build in the functionality that you could input a hexagon of a different size and it would scale the grid. No real reason, again, just something that was kind of nice to put in, really. So that's the detail functions here, a couple of bits. Going off into the, it says 1, but it's 0 based, so input 0, 1, 2, 3. Looks at the geometry. So if we go to this one, we just pin this. Look here. So the detail function allows me to just grab these values off the geometry. The opposite, which is going to be the value we know we're going to want to use as the basis for our hexagon offset.
Mm-hmm. You're going to multiply that by 2 times, right?
Yeah, exactly. So you can so you can just shimmy that along. The radius, again, to just control the scaling of the grid. So we can build that into the system so that if the input hexagon gets bigger, we can space the points out more. And that's actually all we need for this bit.
Okay.
So let's unpin this. So let's go in here. I think what would probably be easier is if I just hook that there, template this. There we go. This makes it a bit easier. So 2 for loops. I'm not sure how much you want me to explain about these, but
no, you can
for
just explain that general. For example, I think it's interesting that you didn't like you did loops. So for me, it's interesting because the way I've done it, I've defined it a maximum size, and then I just moved the points with modulo and integer division. But in your case, you use loops, so it's to me it's like you went another way. So it's interesting. Just
I think that's what's cool about doing it like this, where we've all had a bash at seeing what we come up with. So we need a loop for the rows and a loop for the columns.
right.
All we're doing in this stuff, this is just kind of interface things really here. Channel integer, calling the value in this box. How many rows does the user want? How many columns do they want? Again, this links back to first loop. How many rows? Again, so for once this loop runs, let's say we only want 1 row. Pop that down
It's adding the points per iteration, right?
All of the point creation is only done in the second loop.
Right.
The only thing that we do within the first loop is, so this is where the modulo is coming in. This is essentially our tick-tock offset to determine whether we offset the row or not. So on the 0th iteration of the loop, this whole thing here will evaluate to 0. And the first iteration, it will evaluate to row offset 0, row offset 0. Offset, which is going to be constant because it can just, let me just more rows in. The Z offset doesn't need to be offset, right? It's just going to be the same amount every time it goes down. It will just go down the same. We don't have to worry about doing anything particular with that.
Yeah, if you can take the extra X-ray x-axis offset that you have to give to the even rows, maybe it becomes really obvious that you you just had to worry about for the even rows, right? So the even rows you did. Okay, sorry, go on.
Oh no, it's good to. Sorry for the noise, name road.
No problem.
So okay, so we're on the first. So the user wants one row, 10 columns. So we're going to run through the first for loop once, and then within that we're going to run through this for loop for as many columns as the user wants. In this case, it's 10. So hit this 10. Going to run through this 10 times. I mean, it's sort of. I guess it seems simple because.
If you want, I can draw a little bit about that. So it's okay.
If what, sorry?
I was saying if you want, I can draw a little bit about that. It's okay because you're talking about what's behind the offset, right? What's
yes,
the mentality behind the offset. I was just saying if you want, I can draw a little bit about that. I think I made a little sketch that I shared on the server, but I don't have it at hand now. But basically,
I think.
Yeah, basically, it tried to serve as a guide for the mindset of the thing. But if you want, I can draw it. Otherwise, I think it's not needed. Go on.
I really don't. I may as well carry on with this bit, and then we'll get to the sort of more fun visual stuff. Because this is just like the setup. So This is it really. We're just gonna make some loops, and then on the however many times we want to run through, we want 10 rows. It means we're going to run through the whole loop 10 times, and we're going to run through this 10 times for every loop of that. Because this here is controlling the tick-tock, and this is going to evaluate to 0 or 1. Sorry, not 0 or 1, 0 or row offset. The X offset in the second loop here means that it's just going to either, have a row that is not offset, or it will be offset, or it won't be offset. That's really all that's doing.
Okay.
The row offset here, which is the opposite length, so this is the distance from the centroid to the edge, straight along the x-axis here. We know that we want to offset each one as centroid to the center of the next hexagon, and then that's just multiplied by the loop iteration. So in this case, it would be j. This runs through. I is going to be 0, so pretty much everything does evaluate to 0, places the first point of the origin. So in the next loop through j is 1, so the phase this is going to evaluate to row offset times 2. There's no x offset to put in there because this is evaluated to 0, so it's going to place a point here, so on and so forth.
Nice.
So this gives us the basis of our grid, basically, and just the rows and columns is the amount of times you're just going to run through that loop. So this draws out from the origin, which is kind of fine, but to me it's not like super intuitive. If you wanted to resize a grid, if you drop down a grid and you resize it, it resizes out from the center.
Yeah.
I'll skip the UV texture points bit for the moment, so we'll just get rid of that. So that's all center grid is doing here. So that means that once we resize it, it does it from the origin. If that makes more sense.
So you got the average position.
So you see this like detail function popping up just to like grab attributes. If we look at if we look at this node here, because this one here is going to have to run over points, the detail attributes that we need. If you want to grab them from within this code, you need to use a function to go and fetch them, basically. Just regular variables, we're not going to need to use these after these. At least that's what I found. Throughout the process of doing this, I was having stuff stored as variables, not stored as variables. Sorry, stored as attributes, not stored as attributes. It's kind of nice. You don't want to store absolutely everything as an attribute. The memory stacks up. Anything that you're only going to use once, just have it as a variable. You can chuck it away once this. Once this code is done,
I was wondering about that the other day. But can you change the variables? Can you set them up with new values or not? They don't change.
Yeah, well, within this code block, you can change them. Once we've left here, like once we're at this node, this doesn't exist anymore. This is only for within this block. So you could take row offset after setting it to the value that this detail function returns, and you could do whatever you want with it. You could multiply it with something else.
Okay. Cool. But you can change the value as can you change the row offsets further down the line or not?
Yes.
Okay,
Yeah.
Cool. You can. Cool. Okay. Cool.
So this is just a minus equals offset. Gets the columns value 10, times it by row offset, which in this case is 0.866. And minuses it from the x component of all of the points that it runs over. So that's what that's doing. Just make sure that no matter how big you make this, it's always going to center it nicely around the origin.
Cool.
Yeah. Here I UV the points just so the the part of the brief that was to get color onto the points to use that as like a cutout works. Nice thing about UV texture, as opposed to a UV project, is if you have a look at the UVs, you bring the points up. If we increase the rows and columns, you'll see that it's essentially fitting them into the UV space. The bigger you make this,
Yeah, it's working quite nicely.
Thing. This will just auto update. So once we attribute from map, which all that does, this actually probably give us a few more points to work with. Here we go. Hello.
Nice.
Attribute from map, grab an icon, and this is going to export this into the CD attribute. So color diffuse, this is just your standard, bog standard color channel.
And you do this
into
way
here.
because it's a bit more painful to do this with the VEX code, or
it's just you'd have to load a file off of disk.
okay.
You can do it in a VOP if you want. I'm not sure where you'd start doing that in pure code, but this is just one of those nice, easy
ways to go about it.
Yeah, it's just simple. Like you could use a texture VOP in VOPs if you wanted, and output that to the CD channel would be the same thing. This just gives you an upper level view of it. It's just less building basically.
Yeah.
So we've got all of our points colored. Now we need to delete some based off of a threshold. I'm just using simple if statement, and again, like it's nice where possible to chuck these things out as channels so the user can control. It's nicer using a slider.
Yeah, nice.
Than it is picking through a number and going, does 0.5 work? No.
Yeah,
0.6?
yeah,
no,
definitely.
Yeah. Reason for picking the green channel, because I know I just wanted to delete white, so it didn't really matter. But yeah, all this does is it says, it's an if statement. If this condition is met, then execute the remove point function. All remove point does is it expects two arguments. The first one is the geometry handle. So 0 is basically just itself point you want to remove. In this case, it's the point number, because this runs over every single point concurrently. So it's going to go off. It'll be looking at its particular point.
Right.
It'll say, is your CDG, CDG here, this attribute, is this larger than this threshold? Get rid of it.
Right.
This is one way of writing an if statement. If you want to, because it's just basically one
line
thing of it. You could also normally.
Yeah, that was I was looking at it. Oh, that's an if statement. Yeah, because usually you see it like that. Yeah.
Yeah, it just saves 2 characters. I still nearly write everything like this anyway, just in case you want to start putting extra things in. It's just easier. But yeah, it's you've just got one condition, one thing that you want to do. You can put it all in one line, and it's happy. It doesn't really complain.
Cool.
Okay, cool. So now we've got rid of the points on the grid that we don't want. So we're sort of like starting to build the template for what we want to copy onto. This is really like the meat of point instancing is, or just generally this technique, and why it seems so obvious to use this. Houdini, using the copy to points node, you can take some basic input geometry. So in this case, it's just our simple little hexagon. Quickly copy it onto a load of points, and there are a certain set amount of attributes that Houdini has built in that will determine what happens to those things after they're copied on. So this bit,
So in this case, you're using P scale.
Kind of, yeah.
Mm-hmm.
P scale is just the go-to. It's just like a float value for controlling uniform scale of anything that you copy to it. So it'll apply that to all axes, just a uniform scalar value. There is a list. I don't know if I've still got it up. Maybe we can just like link it in the description afterwards. But
Sure,
there's a
sure.
list of attributes
Yeah.
that who you'll recognize for instancing. Yeah, P scale is one of them. You can have
Orient can have Orient.
yeah, Orient,
Yeah. I'll link to
vector.
that list. Yeah, for sure.
Cool. So we can go through all of that. The Again, like the nice thing about making sure that the radius was taken into all of the grid spacing and everything else was that I knew that once the grid had been made and P scale was 1, everything would line up. All of the hexagons would be, meshed together nicely
Mm-hmm.
with no space,
The space was all
which
filled
makes
up. Mm-hmm.
yeah, which makes in fact I can just kind of this. So this is our nice hexagon shape, no spaces. At this point, there's technically no P scale, but that's just because it defaults to 1 under the hood. So let's just go back to here. Yeah, if you know it needs to go between 0 and 1, it just makes like animating everything really easy. You're not dealing with any crazy arbitrary numbers for scaling stuff. It's just always going to be a really simple fit this between a given range.
So if you scrub the timeline, yeah.
I'm afraid I'm no animator, so I've just basically ran all of this through a sine function.
Okay. I find funny that you used rand and not noise, because rand is it's not going to have a smooth transition between one frame and the other. So you could try.
Well, that's
You could try then also see with noise that might allow the polygons to grow and shrink slowly instead of just being a random number. Because at the moment they just sort of switch very rapidly, right?
the actual growing and shrinking is going to be mostly controlled by the sine wave.
Ah,
All the
okay.
random is doing is offsetting that per point.
I see what you
So
mean
you're
now.
not so you're not getting like a flickering. All the animation is going to do is just going to rise and fall, rise and fall. Yeah, the random part here is just offsetting that per point. So
Okay.
that's why, because otherwise, I mean, I can show this. If we put this to 1 and 1, so we're not actually randomizing this at all.
I get it. Sorry, I misinterpreted what I was seeing there. Yeah, 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 yeah.
So now this is the same sine wave applied to every point,
Mm-hmm.
same value.
Right.
Makes no difference. This kind of acts as sort of like a random controller in terms of how random you want it to be, pretty much.
Okay.
Arbitrary values sort of for this. It went up and down. That seemed fine to me. Then, so we store that in the result of that entire bit of mess there. We can then use to drive other things. I've chucked in another scale here just in case, for example, you didn't want them to go to 1 all the time, so you could make sure that the max size was 0.8. So at no point would they ever, get close to touching. Again, it's just they're all quality of life things, calling channels where possible rather than hard coding values. So people just have more control. This is like a really nice, easy thing to say. Oh, this just makes it do.
Yeah, to grow them all or shrink them all and just have them come up. Yeah, definitely. Because then you can
Yeah,
plug.
this is just like a
You,
go
you,
on.
you can plug then something else to that. You can plug a linear fall off that you can make them all just like show up by controlling, like by connecting that offset to something else. So yeah, it definitely can
Yeah.
expand the setup with that. Yeah.
Yeah, and I think that's what's just so nice and easy about doing this, because you can calculate a load of attributes, stuff them on your points. Copy to points will make sure that your geometry inherits those and control. There's almost kind of like a lot of automation about how it's controlled afterwards, which is it just, to me, it's very like intuitive. We will ignore this little bit for now, and also the distance. Again, it's just kind of examples showing the strength of point instancing as an idea. We've got an attribute promote, which creates a p-scale max. And all this is for is so that when we recolor it based on a ramp which expects an input between 0 and 1, I did this in a bot. Here we go. Here's some codes. It brings in, because we wanted the color to be driven on the p scale. That was the brief. So we bring in the p scale, which is what we're going to remap, and all the fit range is doing here is it grabs p scale max. If your p scale is 1, this is redundant, but again, it's just sort of like building in something there's like a little bit of robustness to the system where the user doesn't.
It can adapt to the greatest p scale around, and basically
exactly. So
fit the gradient, making sure that you always show all the colors of the gradient.
Yeah. So even though these are getting smaller and smaller, you can see the largest one's still going to be colored the same. That's really all that is there doing.
Yeah, nice.
In fact, maybe if I leave that there. That just becomes the source max of the fit range. So it knows we're pretty sure they're never going to be below 0. We could build something in to fix that as well if we wanted, but it's going to remap whatever that is to 0 to 1. So our ramp's going to be happy, and we're just putting this out into CD, color diffuse. At this point, we're basically just overwriting CD, because here our CD value is only useful for as long as we need to determine what points we want to delete. After here, if you wanted, you could just get rid of it. All it's going to do here is overwrite it. It's not, maybe a bit of laziness on my part. So then we've got all of our things copied on. They animate, they change color depending on how large they get, and drift off. The other couple of things that I built into this, and again was kind of to show attributes and data flow and all of that kind of thing work, is I made a dist attribute based off of the p scale, which again this is kind of like a bit slow and lazy, but it's enough to show the point. Use that to drive a poly extrude further down the line, and we can have it extrude a greater distance depending on how large or small the hexagon is.
Just like you control the color.
Sorry for that.
No problem. They're coming for you. So just like you control the color, you're controlling the size of the extrusion. Yeah.
Yeah. So as they get bigger, they also get taller. There's another way you can do this. You could have input an already poly extruded hexagon.
Yes. Because they all look similar. They look similar, just different scale in a way. Because
yeah.
So
another thing you could do is, I'll try and do this live, and this will probably go horribly wrong, but let's give it a bash. So let's get rid of the scale, and I'm not sure if we're actually making p-scale anywhere else. So this is with p scale set to 1.
Yeah.
Like I say, p scale is like just a scalar float value. It's going to try and scale everything in either direction. Another point attribute that's recognized is, I believe it is just scale.
Yes.
So if we set this to 111, obviously this doesn't work.
Yeah, actually, I was expecting to work because you're right.
Ah.
There's that attribute. But
Let me just comment out some of this other. I'll tell you what will be easier.
But you have to you have to do set. The error there is that you have to do set.
Oh no, that will still work because I'm using a constant, so I'm not creating the scale based off of any value. So that should still be fine. If you wanted to.
I've never done it that way.
See, yeah, there we go. So we can. This allows us to scale the axes differently, basically. So yeah, if we wanted to drive this by something else, so then we'd have to use set. So we can say like 1.
Always learning.
And let's just like call random again because it's nice and easy. That will give us a value between 0 and 1. 1 for Z. Don't need 2 semicolons. There we go.
Right. Looks nice.
So yeah, this is just another way of doing it. So you can have everything, different heights, and yeah, it's just like another point attribute that you can manipulate to give yourself a certain look. So if you didn't want them to also get smaller and you just wanted them to go up and down, this would be a nice way of doing it.
You can, for example, if you multiply it there by, let's say, by 3 or 5, you start to have like small towers, right? If you connect that one.
Yeah, sure. And again, this would be something where I just, you want to really like throw in a channel, so it was nice and easy to to control that kind of thing. So you could just do like times, channel, scale. This will all go down to 0 because this isn't calling anything; it doesn't exist. But as soon as we hit that, bring up our parameter here, and then we have a nice, nice user-controlled scale. You can make, yeah. Great. I do this kind of thing. You just do all the time. It's really nice and easy to make your own little, tools.
Your own UI. Your UI, yeah.
Yeah, exactly. Which if you're then passing that off to a load of other people to use, and they don't need to worry about the guts of it, you can just say, yeah, there you go, control these things. And someone who's better at animating than I am can decide how all of these things grow.
Yeah, you can create hooks for them.
Yeah.
Okay.
So let's rid of that. My poly extrude doesn't seem to be very happy. Okay, let's just look at this. That I built into this, which isn't really particularly useful, but if you wanted this to be a fixed size, let's just turn that off. And a couple of attribute promotes gets the maximum position, minimum position, and fits that between a certain range. Again, that the user can control. So you just have, if you wanted to stretch it out, it just makes it easy to, even if you've got, say, like, I know that I want it to be 100 by 100, but I want it to be more dense, then this becomes like quite easy to make this.
Make it happen.
Crash my computer, but that's fine. Yeah. Oh, there we go. They're in there. yeah, again, it's just trying to build something that was a little bit more friendly to mess around with. So just turn that off. And the last thing, again, to just really hammer home the point about attributes, have this this little thing here, which is basically saying once the p scale gets beyond a certain, or if the is beyond a certain amount, set an intensity attribute to 1. All this was for was to pass into the shader to control the values in shading. Again, this is, we'd sort of mentioned it before, but one of the really nice things about doing it like this is all of these attributes you can use at any point later on down the pipe. If you feel that you want to control more things based off your p-scale for shading or anything like that, you can just chuck it on the points. You can bind it in the shader. I have a super simple one here, which is just grabbing that intensity value and using it to drive a I read that you can make that value CE and the shader should pick it up automatically, but for some reason that wasn't working. So either way, this works. It's a bit more manual, but it doesn't really matter. So
Yeah,
little render.
like that little thing. Yeah, this looks nice.
Yeah, gets to a certain size, flicks on, and this is that kind of thing where you can just pass all these attributes through. Find it pretty straightforward. It's quite intuitive. Yeah, pretty much it.
Cool. Thanks a lot, Adrian. To me, I learned a few things from. First off, it was interesting that you did with loops for me, because I was so focused on my way of doing it. I forgot you could just do it like that, and all those tidbits of Vex was really interesting. Hey, Messiege, are you on the Discord?
Yeah. Sorry for
Okay.
being late.
No problem. No problem.
Oh hey, that's my.
Thanks a lot, Adrian. So I'll share the link for those copy points attributes you were talking about, and
Yeah, and I'll upload the hip file so anyone else can have a look through it. And
just thanks for taking the time to do it, and for using. I was gonna make a joke about what were the VOP nodes that you used.
oh, well, okay.
That was just making fun.
We've got at least 4 there, and I'm pretty sure these are all nodes.
Yeah. I was just kidding about that. Okay.
Defense, I tried.
No, it's great.
God, I don't get them.
Otherwise, everything's gonna be the same. Like one of the issues with the live stream that I did the other time is that I was basically repeating. Well, it also has this interesting part, but I felt like I was repeating the same exact thing in the same mindset, just in another application, and so it had some repetition to it 4 times, right? So it's like, maybe this, it gets a bit boring. Of course, if you're just seeing one application, say, oh, I'm going to see the one that I want and I'm going to be done with it. Well, okay, you're not going to see the other ones, and so it's okay. But but if you're trying to sort of look around, it looks quite, oh, I've seen this already. But yeah, so it's nice. It's nice that there's some variation, definitely. You're going to
Cool.
You're going to show something, Mark, or
yeah, if you want me to.
Well, yeah, I
do.
I can show my the same sort of thing that I've done in Lightweight, but I don't mind going last.
Let me try if I can get my screen shared.
Yes,
I'll stop sharing mine.
You will go to your left side, and there's a green button.
Yeah.
Okay.
Trying.
There you go.
trying to send it up. Can you see something?
Yes.
We can.
You can. You can see.
Yes, yes.
This
I think it doesn't make
alien-
sense to.
Go on. Sorry.
What I wanted to say is it doesn't make much sense to just repeat what Adrian just presented, and I do have this video on Vimeo anyway showing the. But what I wanted to add maybe to what Adrian showed was some variation on the same topic.
Mm-hmm.
I have the fabric scene open here, which basically does kind of the same stuff, scaling the hexagons. But the difference here is what I'm doing is I'm not using a sinus curve for the size change, because I wanted to have each single hexagon
have its own speed
up and speed down.
Right.
So it's all random, and you can see it's changing the behavior.
Mm-hmm. So you could also use the.
That's something
So what did you use to clip the value from 0 to 1?
Yeah, and that's one thing I just wanted to jump in here on.
Okay.
Different screen here, so forgive me if I'm not too productive. It's late for me anyway. So everything that's going on is inside this single for loop. It's the same graph that I'm creating in the video.
Right.
Colored frames around it, and the actual magic is going inside here. What it's doing, it's setting up an X and Y array for the points, getting the data from the image. That's all just the same stuff. What I'm doing is I'm not using a sinus curve for shrinking and
for doing the
growing.
Transition. Yeah. Mm-hmm.
An array. I have an array of float values. So every single hexagon that I have, and I'm not having a full grid, I'm only storing the points that actually have information in them. So where there's nothing in here, I don't have actually any data for these points.
Right.
It's like a VDB. So I'm really only storing any positions where there is a pixel in the image. So the change array has exactly the same size. I'm just grabbing the same size from the I'm getting the pixels here, and I'm getting the size of the pixels here, and I'm using the same size from this array for the change array. And inside the change, I just have values from minus something to minus something. Something means that, let me have a look. Here's my minimum maximum value. It's something that you could expose if you wanted to the user. And giving the shrinking value minus 0.2 is the maximum shrinking value, so it's shrinking rather slowly. And the maximum growing value is 0.5. So if I just run the timeline here.
So it's like you're doing acceleration of growing?
No, not acceleration, because the velocity, the speed of the shrinking and growing is constant, but you can have a different growing rate and you can have a different shrinking rate. If I change the maximum minimum value to, say, -6, then you see it's plopping down quite fast, because most of the random values will be somewhere on the minus side.
Okay.
If I change this to -0.1, then I've basically growing values, because most of the random values will be above 0.
Yeah, I see that it pops up really fast, but it shrinks really slowly. Yeah.
So it's basically just a multiplication of an attribute that controls.
Exactly.
Okay.
Yes, absolutely, exactly that. I'm storing a random value every time that the size of a hexagon reaches 0, which means it's gone in a way.
Mm-hmm.
then I'm getting a new random value for this change array. Or if the hexagon reaches size 1, reached its end of growing, then I'm grabbing a new value for the shrinking. And since I'm not checking value is correct, like the hexagon is at size 1, I'm not checking if I'm getting a minus value now because I have to shrink. I have to decrease the size. That gives me a nice organic pause. See, sometimes the hexagons just stay at the maximum size for some time because they're getting the same trigger. They're getting the size 1 trigger every time again. And only if they get a negative,
when they go back down,
to go down. So I think this is a nice way of getting an organic change to the system instead of using a sinus curve, which is very organic in itself. Everywhere, even if you randomize the width of the sinus wave, you still get same feeling because you can't change the ramping up. You can't change the up and down slides of the sinus wave. So this is one thing that I wanted to add to Edwin's system, because basically our systems are the same, differently set up, but they're doing the same stuff.
Well, I think I remember from your video, Mark, one thing that you were doing was bringing the image in first and only making points where you knew you needed them, right? Rather than
exactly,
I've made the entire grid and then deleted the points afterwards, which I guess would be kind of inefficient. Whereas I'm sure I remember from your video, one of the first things you do is bring in the image, so you can work out only where you need to make.
Because Mark is working with the pixels of the image, right?
Yeah.
Exactly. Yeah, I'm getting in the image and I'm just checking if the I'm going over all the points in the image only once, and I'm just checking if the luminance value of each pixel is above some arbitrary threshold. If so, I'm setting a position. If it is not above the threshold, then I'm just ignoring this position altogether. So the XFO, which is this transform array that I'm creating, is only getting a value for each pixel that is set. And that's, like I said, that's basically what a VDB is doing. A VDB is only storing information or density information, for example, if you actually have a value. If there is nothing in a cell, in a grid cell, then it's not storing any value.
So you went from 2D pixels to 3D pixels.
Yes, I could have done it in 2D just as well. But well, if you want me to do something crazy, I'm setting the output somewhere here.
Can you make like a multiplication of random like neighbors plus multiplication by texture value plus keeping the randomness? That will be actually cool, probably.
What I cannot do, unfortunately, is the standalone host for Fabric. What I can't do is give each hexagon its own color. That I was doing in Houdini. I was outputting a complete geometry from the complete system that I'm creating, and then adding point colors that I create in the geometry. The canvas system does not allow me to give each clone, each instance of an object its own color.
Really?
Yeah, it's a very
so you can't make like grass or leaves with random.
You can write your own OpenGL shaders, but the video that I did, the idea there was to connect the two systems, to connect Fabric with Houdini and use Fabric for the geometry creation and the color creation, and Houdini for the display.
Yeah, probably.
So yes, you can do it, but it's rather complicated.
To do everything here in Canvas, you probably would have to have a U strip and for example, an image that gives you a U strip, and you would have to say, okay, I'm going to attribute to a UV position along this image, say on red or on blue, or so you would have to have another image to do that and display here, because you can display text UV texture
Yes.
mapping,
Yes.
right? So yeah, you would have to
Correct.
recur to rec to
Yeah.
something like that.
What you could do is you could actually display points, and you can give color to points in the Canvas OpenGL display. But like I said, because this display stuff is not meant as any kind of preview, it's really just a helping system to let you see the geometry that you're working with. So let me do something crazy here quickly.
But
Somewhere
you can like make attribute that you can load later in Houdini to display color.
That's what he showed in the video. Message.
That sound is so cool. I need that sound for my.
I'm really sorry.
Can you sleep well? Can you sleep well at night, Adrian?
Like a baby.
Like a baby, great.
I have the sounds all the time, like bikes at 4 a.m., 3 a.m.
I'm really sorry. I should just mute my mic whilst using the Discord web app. I can't do the push to talk unless the screen is in focus.
Yes, that is true. That's why.
Oh, really? No, I didn't have that problem. Basically,
I'm using the application, but yeah, the push to talk.
The push to talk. My mic doesn't work.
Had you guys talking with yourselves today in the beginning, so that was a bit bad.
Let me quickly restart this. I did some boo-boo.
Yeah, I noticed that.
I think I messed up my Python library, actually. I was developing some Python stuff the other day, and I think I somehow messed up my Python installation here, because I'm getting all weird crashes with Python here.
Even if you use it on other places or just here in Fabric?
Everywhere, because
okay.
I have to develop in just about every.
Python is live. Python is live.
Yes. You're outside.
So let me quickly retry this. That's actually one of the funny things you can do with storing just the positions that you're working with. So let me run this on, say, 12 frames a second. And yeah, we're starting to get some nice wobbling. Single hexagon with its own complete transform, I can do stuff like adding turbulence noise to this. So if I compose a center, and then maybe, I hope this comes through. Yeah, I think it comes through on the system.
I think the stream. Oh,
yeah. They never get you, Adrian. They always pass by you. Looks nice.
I think you get the picture. Since I got every single point with its own transform, I can just add whatever kind of noise and turbulence I want.
But tell me one thing, Mark. The same speed, like the speed that it takes to grow, and the speed that it takes to shrink, it's gonna repeat, right? So let's say that it's going to grow the first time, and it's gonna take, like, let's say 1 second. And it takes 0.5 seconds to shrink. Then it's going to take again 1 second to grow, right? It's
no. because every time a hexagon reaches a threshold, like 0,
Yes.
meaning it's vanished, or 1, it's got full size,
Yeah.
I'm grabbing a new random value.
Okay. I see what you mean.
Negative, which means shrinking, or it can be positive, which means growing. And if the hexagon is at size 1 and I get a random value in a positive range, I would get across the threshold again, so it just stays at 1. And this gives me this organic pauses sometimes where the hexagon just stays at maximum size and then falls back to 0 and gets up again. So it's really all random.
So it's working as a simulation, right? This part of that.
Yeah, in a way, yes.
Like everything else doesn't need to be simulated, but that part that you're talking about specifically, you really need to build up the values as you go on time.
Yes, a simulation. Yes, I do agree.
Okay.
Right.
Okay.
This is another thing that I wanted to play with. Screw up here. In the y value, and if I add a node, and this is the exponent, I can then, it's maybe a bit much.
It didn't crash. Go up.
Maybe I should
save a version.
No, I never save. Saving is for amateurs.
How are you making products in Modern?
We do it every single time. And don't get me started. I had to use that program all weekend for some clothes simulation. And I'm not going to go into any details. What I wanted to do here.
In Modern clothes simulation? Wow.
Yeah, I'm doing all the clothes simulation for a movie, for a Terry Pratchett movie. And since they're rendering and since they're doing some part of the animation in Modo, I have to do 2/3 of the clothes simulation in Modo and the rest in Houdini. Anyway, this was something that I wanted to add. If I grab the size value and put that into an exponent of a math power function, I can give this, using the wrong screen here, give this y axis growing much more vivid, much more energetic feeling to it.
Yeah.
Same idea that Adrian was showing, just adding some math power to give it more accentuate.
I think that I realised why you thought that it was popping based on the use of PT-num, because the frame rate of the screencast must be like one frame every 5 seconds or something. Everything looks like it's popping.
Yes, I'm feeling like terribly sorry about it, because is it like for your because it also for your Hangout, you're seeing it on the Hangout video, right?
I'm just seeing now.
I get something about, I'd say, 3 to 4 frames per second.
Yeah, it's hard to.
I think that's probably what I'm at.
But in the program, it's like full.
Can you go inside, please, the turbulence X-form?
You mean this one?
Inside the turbulence X-form, please.
Yep. It's just a wrapper for. And inside here, you probably see some code. In the end, you're all getting back to some to some code stuff, of
Some
course.
snippet. Maciej, you have to get closer to your microphone. You're getting a bit too far away.
I think that was Spiny just, if I'm not wrong.
Oh, that was.
I think that was Spiny, wasn't it?
Ah, okay. Let me
Yeah,
check.
Yeah, it was Spiny.
Oh, okay.
It was me. I have problems with my microphone, but I'm really interested in this because I never saw that you can turbolize a matrix.
Well, you can turbolize the transforms. Turbalizing the matrix components might not make a lot of sense.
No, I saw a code and it looks like a vector.
Oh, okay. But well, if you turbolize the matrix, you're gonna get like very skewed transformations, right? If you turbolize the component, like the right, up, and forward, you're gonna get like, you know, crazy stuff going on. But if you turbolize scale, rotation, and position, it's gonna.
Yeah, but how you can turbolize a matrix? You can't turbolize. You can change the values inside, but you can't turbolize it.
Yeah, but turbulizing is really just changing values. I mean, if you look into the code, you see in the end what it's doing is just adding some Perlin noise. Mm-hmm. So we are only dealing with values on vector components anyway.
Yeah, but on points you are manipulating the noise, not on a matrix. Because the input is a matrix and the output is a matrix.
That's up to you. I mean, just adding values to some parameters. That's it. Okay, it's up to you what you do with it.
Yeah. Okay. Here we are. Okay. Yeah, you're manipulating a vector. It's okay. I really was confused. Okay, it's cool.
Don't get confused. It's all fake.
Yeah. In the case, it's just.
It's a vector. Okay.
It's a vector. Calm down, everyone. It's just a vector. It's not a matrix. Put your guns down.
No matrix was harmed in the making of this tutorial.
It seems like.
I just wanted to ask you, Mark, like for you, since I'm curious about Fabric, but I haven't paid the price yet of sitting down and okay, I'm gonna read the documentation. Like, I'm the guy that I wouldn't mind having manuals being comic strips. So so for you, what do you like? What's you really like about Fabric? As much as you have been using it, what's the thing that you, when you're thinking about something that you have to do or maybe you have to develop, you really think, okay, now this I'm going to do in Fabric because of this and that.
Well, first, when I develop, I have to develop in whatever language the client wants me to develop in. So I'm doing Java, I'm doing C++, I'm doing PHP, I'm doing JavaScript, I'm doing KL, whatever. It doesn't matter, because for me, development is three quarters of the time is language. It's getting the problem sorted out. With that said, it doesn't matter if I use Houdini or Fabric or whatever, technically. The thing is, I personally, that's a completely personal thing, nothing else. I personally feel fine with the editor. I like the way the canvas is working. I like that I can look for a function, say I'm looking for a polygon mesh, and I get all the detail information over here. So I get a short description, I get some documentation in the search function, I get all the input and output ports listed up. So I have all the information available. If I say I want...
Softimage had a SDK Explorer, and so it sort of feels like that, yeah.
That's one thing that I like. I usually don't solve problems nodal on nodal base. I don't do this. I'm always trying to do it, and I took on the challenge. I love that, to do something really only just in noodle graphics. But usually what I would do really is... Pardon me?
What are noodle graphics?
I think he's playing with the words.
Yeah. This is pasta. Yeah. Spaghetti.
Spaghetti.
What I do is just
Usually
just write.
you go there. Okay.
I would just write code.
Okay.
And the thing is, doesn't really matter now. It's just trying to underline what I'm saying. Thing is, I have an interpreter and a compiler in the same system. The output of Fabric, when I write KL code, which is basically the same stuff as VAX or JavaScript, it's all the same language.
Right.
It's
Do you
not
have
Python.
multidimensional arrays in
It's
Kyle?
the other language. Pardon me?
Do you have multidimensional arrays in Kyle?
Yes. It's quite difficult to do it in nodes. You can construct something, but it's not really fully implemented in a visually pleasing way. In code, it's not a problem at all. You can have as many dimensions as you want. You can have dictionaries, you can have numbered arrays, you can sort the stuff. It's all not a problem at all.
That looks pretty dope.
Which is really quite mature.
Recently, I had to fire some feature requests. So because of arrays, and so here I would guess this, just like ICE, the operations with arrays are quite easy here, right? If you want to add an array to a single value, you can just put an array and an add node and add those together, right?
Yeah.
Like when the port of the turbulence, for example, on the port of turbulence, I noticed there's some parentheses there. Oh, okay, everything's good. Okay.
Let me just quickly do something here. Get a cube, XFO array.
Okay.
And
if you put what do you use to apply the XFO's transform node, something like that?
Yeah, XFO is a transform. If you compose an XFO, you have access to the orientation.
Okay, where is the reverse of that, of XFO to transforms? Or like
XFO is a
decompose. Yeah, decompose of it. Okay, there's that. There's it. Okay, so if you plug the XFO array into the value of that node that just put in there, the output of the XFO array into the value of the node that you put in last in the network.
Yeah.
What happens? Can you just connect it? So that's
if you want to add something to an array, you do a push.
No. I just wanted to see if the port updated. So if that node that is on top that converts XFO to transforms, yes. Could you connect the XFO array to the input of that node?
You can't connect an array.
Okay. I was
but
expecting.
You can do.
Okay. Yeah, but what if you want to control? What if you want to convert the array of XFOs into an array of rotations, or an array of scalings, or an array of translations? That's what.
Then you do a decompose XFO array.
Okay, it's very explicit about it. Okay.
It's all there. And if something is missing, you basically create your own function. Okay. You just say, this doesn't make sense, obviously, but this is your new function. This is your new node, and say you got something exposed here, and you got something exposed there. You got those parts here. Then you put that into a preset. Where's the create preset?
Create new preset.
And then you can just
decompose.
this function, this node, wherever you need it.
Okay. Okay, cool.
Do we have decomposed in Houdini?
What do you mean the Yes, we have. Yes. It's called
In Houdini.
extract. Yeah, it's called extract transform.
Okay, really?
Yeah, there's make.
Trying to
Go on, Mark.
back to the question, when or why do I use Fabric? And there are two other areas where I like to work in Fabric, and one is aside from being able to write my own extensions in kind of about any language, I have access to multi-core processing. I can write the same code and just put it into multi-core processing, or I can even push it over to the GPU and have it executed on a GPU. So I have full control over multi-core processing stuff, which is quite nice for the stuff that I do for money, dealing with huge amount of data.
Nice, I see what you mean.
Of images, and each image has 10K times 10K resolution. You're really happy if you can leverage a couple of CPUs to just deal with the data.
So
that's one thing.
You feel like it's a drawing board that it doesn't.
That is exactly
constrain you very much. Okay.
Yeah, it's really an experimentation system. I can just throw stuff together. It's quite stable if I don't mess up my Python installation. That is quite stable. It's very fast. It's very performant. And another thing that I in Houdini is control over evaluation. I can stop, I can break evaluation of a graph wherever I want, not just by bypassing single nodes, but by caching or by storing variables anywhere. I can access the same variables, the stored variables, over the timeline. What you do in Houdini with a solver, where you have access to the previous frame only, you can store anything, polygon mesh, an array, or anything that you want, or even your own struct. If you define your own struct, if you define your own class of something, say a polygon mesh with additional transforms and what's not, you just define that and store that into a variable. You have access to that variable wherever you are in the timeline. Doesn't matter. You always have read and write access to that. So you have global variables and your own class structures that you can define. You can do that in Houdini. That was something that I tried with my spider rig, the first experiment that I did in Houdini. But it's really complicated. You can do it with the HDK. You can do it with Python nodes. But you run into evaluation problems with Python nodes. So this is really something, if I do something in animation, if I do something in complex simulations where I want to be able to scrub back and forth and really have the stuff re-evaluated based on data that is stored into some variables, I feel like Fabric is giving me the freedom that Houdini have. It's getting there. I know they're working on that stuff, but this is really something where I have absolute full control in Fabric. On the other hand, sure, there's a lot of stuff missing, like the OpenGL port is really limited in use. They have something in the works there, their real-time rendering engine, but it's not available yet. You don't have the huge vastness of functions that Houdini has for visual effects. But I think Fabric is not tailored towards visual effects. It's really a pipeline system. It's something where you pipe in any kind of data, you do something with the data, and you just pipe it out again. Like, I have done a lot of alembic cache fixing in Fabric by just deconstructing an alembic, correcting the values, and just piping it out again. And that's really straightforward in Fabric, because you have this just plug a node in somewhere and see if the result is correct, or just use an Alembic checking node and see if you get the result that you're after.
Without having to build your own full application from zero to process those things, right?
We don't have.
But let me reiterate: it's not that Fabric is in any way better. It works better for me personally.
Right.
It just clicks right. It does have some technical advantages. It does have some disadvantages for sure. But for this kind of pipeline work that I'm doing mainly, solving problems, solving pressing problems, getting something done within very short time that's performant and stable, that's where I feel comfortable. I think that's the best answer I can give.
Right. Cool. Thanks. I just had one question. You mentioned that you could build extensions in any language that you want, like Java. I don't know. You mentioned that. So what you're saying is that you can access some libraries and interpret things in that language, in any language.
There are some loops you have to jump through. What you can do is you can access dynamic loaded libraries, DLLs. You can on any system that Fabric supports, like Mac and Linux and Windows. You can access compiled libraries. The system is a bit crude. It's the Fabric developers are very Linux affine, so they're doing most of their development on Linux first. So you have to jump through some loops. But technically, yes, you can plug in any kind of system that you have in a way in some kind of library. So to answer the question, can you work in any language? Yes, as long as you can wrap whatever you need into some kind of access. What you can do is use Python as a middleware. What you can do is use KL, the scripting language in Fabric, as a middleware. So if you start, for example, you can start external programs from Fabric Engine. So you just start an external program, say a Java interpreter, get some results from there, and just pipe that back into your running system.
Nice. And that's just like, say, a node in the thing, or no? It's for you. It's not a node.
If you set it up that way, if you create your extension, in a way that you can. Unfortunately, I disabled my own extensions, as I could have shown you. I don't think I have anything here in a. I created a couple of experimental extensions. Like I wrote my own gas and smoke solver and so on. I started playing with this library stuff, just getting in for image manipulation and getting in free type fonts and so on, so that I have access to the stuff that I do for a living, which is printing stuff. Right. And that works. You create it's like a definition. It's like a list of functions that you just convert into presets, and presets are just these nodes. Where's my cursor? Just these nodes. Get your functions in this Explorer, and you just drag and drop the function over, and it all immediately pops in with the correct import and output ports, just as they are defined in the library.
Yeah,
so it's pretty straightforward.
You're talking my language, because I really like, even though I don't know, sometimes it seems that for someone that doesn't have that big technical background, I seem to waste a lot of time on the building blocks. But that's because when I'm assured of my building blocks, of my vocabulary, like you're saying, you said dictionary, I say vocabulary, but I think we're pointing out the same thing. When I'm safe of those, I feel I can start to then go to what I was supposed to be doing in a way, because then I have my tools to start working. And so, yeah.
Exactly. Yeah. That's what I said, or just that's what I meant by 3/4 of the time really is is outside any language. It's really breaking down the problem into chunks that I can digest and then solving each single chunk on its own. And as soon as I know how to solve the problem, I can grab whatever system. It really doesn't matter. I feel comfortable in Fabric, but it doesn't matter.
Right.
I can do it in PHP. I can do it in BASIC. It really doesn't matter. It's always a question of where does this stuff get implemented? What performance do I need? Is there anything like I had to work with EXR, OpenEXR the other day. Doesn't really make much sense to do that in BASIC, obviously. So I'm using some C++ because I can use OpenEXR as a library there. But that's really a maximum of a quarter of the whole development process, because as soon as I'm at the stage of writing code, I usually know exactly what I have to write. It's just writing that stuff down.
Yeah, now you're talking again, like you're appealing to some, like, because to me I like to use Node. Like, I don't like much code, but I like to get to flesh out the ideas in Nodes, just because it's faster for me to like having that drawing board there. And so I think you're talking something similar. Like, you're talking about some pre-process before you go down and you actually do an implementation, right? You're talking about fleshing out the idea and being able to assess, okay, this is where I want to go. This is how I solve this problem. So yeah, I think this is how developers this is how I develop. Okay.
Yeah, really, it's not joking. If I create a database, I've worked on really large database systems. If I create a database, I usually start out by something like this: user.
Obviously.
and this is how I develop. And then I have a role, and then I have a position. And then I have an attribute. And now I'm completely messing things up because users don't have attributes. Okay, so, but this is how I develop, and this is how I develop software. And my software usually starts out by something like this. And then I got a pile of paper, or I got a number of JPEG files or whatever. And each one is really describing one single problem. And know how to solve this problem.
In a way, I envy you. In another way, I don't, because yeah, that takes like amount of structure. Like, you're doing everything very structured. It's cool. It's cool. No, it's cool. It's cool.
Sounds good. I don't feel that way though.
In the long run, we're talking about the long game. Right.
I'm definitely more of a run around and make a mess kind of person.
Yeah.
In a perfect world, I can go back to a single chunk and replace the solution I found with something else. Unfortunately, I don't live in a perfect world, and unfortunately, I live in a world where clients want to get some solutions like now,
right,
and skip this part of the development and just write the code, hope that it runs, write my invoice, and seek the next door.
And run.
Quite fast. And only get paid in cash.
Exactly. Bitcoins.
Amen.
Bitcoins from now on.
Yeah. So you get...
Bitcoins got kicked ass last weekend, basically. I don't know if USA or something, but they got kicked like really hard.
Maciej, you have to get closer to the microphone. There's a bit of a noise also. It's hard to understand you. Try again.
I was just saying that the Bitcoins had like some huge problems last weekend.
Okay.
Thanks, Rajiv.
I didn't get it. It was related. Oh, maybe it's Spinny that it's doing the noise. I don't know.
Some of them decided.
I guess like to be honest, I don't think it's soon enough for me to go on about what I've done. So I think I would just quickly show up what this sort of challenge that I put on to people, the hexagons, worked on me, because I started also with doing. Let me share my own screen. So I think I'm just gonna go quickly over what the challenge for me resulted in. Not going into step by step, but maybe just say, oh, well, this is where it started, and this is what it ended up, what I ended up doing with it. So I ended up doing polygons, and in this case, in Lightwave here, actually, I don't have the scene that I was going to show, but I had instances doing the hexagons and doing the same distribution as you guys were mentioning. But then I decided to do a shader, and it's like, well, why do I need the overhead of geometry? Maybe I can just do this with surfacing with rendering spots. And so in my case, I ended up, so this is the most basic one, which is using quads. This is holding up. Oh yeah, sometimes my Lightwave locks down, and I haven't understand very well why. I think I have threaded mesh evaluation turned on, which is an option that sometimes locks it down. Oh no, it's off. I don't know. Weird. Let me try again. So I tried the most basic one, which is having squares instead of hexagons or triangles. But actually, this was the last one that I've done. The first one was to do. So here I have three branches: hexagons, triangles, and squares. And of course, the squares is much simpler because I'm just going to rely on flooring. And so to get the shape of the hexagons without any geometry, just with shading, just with the position of the rendering spots, the samples, and just out of that figure out an hexagon was sort of a challenge for me. So just gonna share quickly this here. So this is the hexagons part. And so just to be really quick about it, let's say I have an hexagon like this. And so I used integer division to divide this hexagon into triangles, just like Adrian explained. And so with integer division applied to 360 degrees, I would get that this is triangle 0, 1, 2, 3, 4, 5. And then this would give me an amount by which I would rotate these positions. So this position here is a spot, a sample on the surface. And so there's a vector for it. And so I'm transforming all those spots, because this is just, I come here, it's just a single quad. There's not much to it. It's just, I only have one thing in the scene. It's just this quad. Well, actually, I have another thing, but I'll go on about it later. But so I basically rotate all these triangles back into the origin. So when they are all rotated back, it looks something like this. So the 0, 1, 2, 3, 4, 5, they're all here. And then I rotate this a little bit more, so it's aligned with the x-axis. And so after I have this aligned with the x-axis, it's really easy to get the triangle. I just have to check if the position is bigger than this coordinate here. And so this coordinate here, I can get it the same way that Adrian talked about. And so I just do a logic, say if the position is bigger than this, goes to black, and if it's less, goes to white. And so let's say if I can show this in here. So basically I get something, let's see, max color like this, right? So in this case it's black because I'm applying it to the transparency. And light wave locked again. That goes the show. There goes the show.
I think it's because of the GPU, maybe.
I don't know. My computer has been behaving a little bit weird.
Stay on topic.
my computer has been having a little bit bad lately. I don't know if it's the software, because also with Houdini I've locked it sometimes. I don't have a lot of memory. Mark is probably gonna laugh at the amount of RAM that I have. I have 16, so so that's not much. I don't know what you guys run on, but it's definitely showing its age. But yeah, staying on topic, like Spini suggested.
I never laugh at memories.
Oh, damn it. It did it again. Crap. I really did. Yeah, really hate when this happens. Yeah, it's not. It's I don't know. It feels like I'm pricking some bubble, and it just so basically this is used for the masking. Then for the only challenge the only thing that was a bit more annoying was not actually for the hexagons, it was for the triangles, because the hexagons I don't have to rotate them, but the triangles you're gonna have an array like this, but then the next row you're gonna have an array like this. And so that one was a bit more annoying to get, because I had to find the shape for differently. But other than that, you know, it was interesting to me that I started this challenge with something that was mesh based, and then it was just pure vectors. Because here with this one, I don't have any points that I can recur to. The only thing that I have is something that I talked about in the when I was going on about this, is this spacing. Let's see if I can put this up, maybe hide this hidden. So this is the spacing for the triangle. So if these are the points that you see here are the centroids. And so the same thing I will have for the spacing of the hexagons. So this is this no, this is the okay, wireframe. Okay, this is the spacing of the hexagon. So this is the centroid of an hexagon. This is centroid of another hexagon. And so basically, I find the closest. I divide the space in boxes, and I put all those boxes back into the origin. So just that's why the squares one is the easiest one to do. So let's say I have this template with hexagon centers, and so this is my template, and so I divide the 3D space into similar boxes. And then just like I did here, when I put everything back into the first box, I put all the boxes back into this position. So whatever box is sampled on the 3D space, I subtract the center position of that box, and I place it in here. And so after all those boxes are overloaded into this space, for each of the points that I have in there, I find you have to remember it's surface spots, so it's a location in the surface that goes on the render. For all of those positions, I find the closest which of these points is the closest one. So basically I'm defining which of the centroids of the sample of hexagons is the closest one. And that's how I attributed not just the scale, but also the color. And so that part goes on, export. That part goes on in here. So if I find the nearest point on these sample pieces, and then with that, I get on the, yeah, I'm really afraid of turning this on and blowing it up, and yeah, but so that's how that's basically the way I went on about to having some scaling and some color. So here I have, yeah, it really sucks that this, like, you get this, you know, this scare of having something blow up. I get, let's get, okay, let me try to show that. Put this up, and okay, so there's some spot replacement. So spots are these samples on the rendering surface, and so here when I do a replace spot, I'm just replacing the positions that are used for the texturing. So texture assignment uses positions. Usually we use UVs or we use a planar projection, and so here I'm just defining a custom position to be used for texture assignment. So here I have a turbulence texture that if I would just apply this directly, you'll see that it's just basically a procedural. But if I replace the texture assigning position with the centroid of the hexagon that I found, then I get a plain color. And so I do the same thing for this image map that has the Lightwave logo, and that's how I get the Lightwave logo being made out of hexagons. In this case, it's picking up a portion of the image, so it's probably, it's too. The hexagons are so small at this point that, but I can't come. That's supposedly the good thing about this setup. So let me just scale this down and just, this is supposed to, I supposedly set this up for this, so by not showing it, I'm being an idiot. So you can see that basically the same replacement is taking place. So this is the usual texture. By replacing the texture assignment positions with the centroid of the hexagons, I break Lightwave and he freezes. But yeah, it's the image that you've seen before. So on the Lightwave part, I think I'm gonna end that and just going quickly into Softimage and just see where I went after that before you guys kill yourselves. So here I started. So okay, here I was looking. Okay, so I did these 3 2D filling shapes: a square, hexagon, and also a triangle. And so I saw that and I think, well, what about 3D? Maybe there are some interesting 3D space filling shapes. So I went online, I looked it up, and there's also already some references. And so basically, then I did the same thing that I've done for Lightwave, where I understood that I needed to get a pattern, a 2D pattern that I can use to get the closest centroid, like I've shown before. Let me put this up. So the texture wireframe hidden, right? So this sort of pattern, or in this case, this looks squiggly because it's just the order that the points make the polygon. But what matters is the positions of the points. So I said, well, I think I have to do the same thing in 3D. And so, for example, here, this is my sample pattern, which I also use to divide. I divide the 3D space with the size of a box that has the size of the centroid. So there's a bounding box that is made out of the how the centroids connect. The bounding box of, sorry, the hull of these centroids. And so, just like I've said, I would put all the boxes into this single box and then find the closest position. Here I do the same. It's just these are not polygons; these are actual objects. And so I have the position of the object. I use that as what I find the closest position to all these objects. And that's how I end up then with, for example, in this case, I have a sphere. Let me see, which sphere is it? Here we go. So if I unhide, you can see that there's a sphere. And so I can use this to be the template object for this space filling. So it's basically the same thing that we've been doing with the hexagons and that I shown with rendering, but it's just it's just in 3D. And so the same thing here for this one. So this one is a bit nasty again because I have to turn these, so this rotates, this one doesn't rotate, and so on. So it's a bit nasty, but I also have the sample pieces in here. Let's see. Oh yeah, in this case, this one, this was the first one I did. I just used objects position, so I didn't actually have pieces like the other two. But for the other two, I actually have pieces like this one. So this is like a sample. I know this is a pattern that I can repeat in a box-like way. And so this is how then after I can just have this sphere being sampled by those shapes. And so that's it. I'm not going to take any more time, but just wanted to show that that single challenge, it grew went into other places, and I think that goes in tune with the spirit of this Discord server. I hope, maybe, whatever. Are you guys still alive?
I am. That was fantastic. Thank you.
Okay. Okay.
Interesting.
Well, guys, thanks a lot for bearing with me my bad streaming skills. I would suggest we, unless you guys think there's something that you would like to put out there, I would suggest we would end the stream and we can still chat if you guys want. People that want to go to bed, but is there anything else that you guys want to add for people watching, or? I guess not. So.
I think so.
I don't know.
No, okay, cool. So thanks for anyone watching, and hopefully if you like the sort of things that we explore here, it goes along the lines what the reason for what I opened the Discord. And so if you're like-minded, if you go along the things that we've shown, please join, regardless of the application and system you use. I'm really eager to know people from, like I say in a joke, and like in a light way, from all walks of nodes or setups. And so yeah, that's it. Thanks a lot.
Cheers, guys.
Cheers.
Thanks. Cheers.